move to
Yeah, that makes sense.
the next part is integrating or finding the antiderivatives when f of x is uh, displayed. This is a composite function, composition of a function with a linear function, right? So in this case, if we have to integrate a function that is composite function like this cosine of 2x plus 3, you need to apply the reverse chain rule of differentiation. Let's see how. Let's do this first part. A part. Uh, as we know it, what is the derivative of sine? What is the derivative of sine?
Cos.
Sine x, cos x. So what is the derivative of sine
Cos X, yeah.
2x plus what is the derivative of sine 2x plus 3? It will be cosine 2x plus 3
Yeah.
multiplied by, let me use this thing, cos 2x plus 3 multiplied by the derivative of the function in argument. And this you call the chain rule of differentiation, right?
Yeah. Hmm.
That you have to multiply the derivative of the argument function simply. So if it is
Yeah.
linear, uh, then the derivative of a linear function is simply coefficient of x, 2,
Yeah.
because derivative of x is 1 and derivative of 3 is 0. So you get 2 as a derivative of this composite function. So if derivative of sine 2x plus 3 is cosine 2x plus 3 multiplied by 2, this 2. So this 2 is missing here, right?
Yeah.
So what you will do, you will simply you will say that before the antiderivative of cos 2x plus 3 will be, because this 2 is missing, so you will divide 1 over 2, divide 2 outside and give 2 inside, like this.
I see. Okay.
Now, because
Mhm.
derivative of sine 2x is this, therefore the antiderivative of this should be sine 2x plus 3. So I will now write place of this antiderivative, because we know whose derivative is this. Whose derivative is this? Whose derivative is this? Derivative of which function is this? We have just seen that derivative of sine 2x plus 3. This is the derivative of. Are you getting, Damiano?
Yeah. Is derivative. So I don't know what you
This is
mean.
the derivative of which function? We have just seen it.
Um, sine 2x plus 3, no?
Exactly. So I will put
Yeah, okay.
sine 2x plus 3 here. So what
I
is the
see.
problem here is actually whenever we have composite function like this, we need derivative of the in function here available.
Yeah.
If derivative of inner function, which is in the argument, is not available and it is a constant, then you can multiply inside and divide outside. So that to in order to make that constant available, that derivative available, and we will
Oh, I
apply the
see.
reverse of the chain rule. Okay. Similarly, this is just for composite functions. If you see a function which you are integrating is a composition of two functions. So look, it is not simply e power x. The antiderivative of e power x is same e power x, right?
Hmm.
But if
Yeah.
we have e power 2x, not x, then it is a composite function now. It is e power 2x. So
Yeah.
in order to integrate this, you need a derivative of the power to be multiplied with e power 2x here. Here. What is the derivative of power? 2x. What is the
Just
derivative of
two.
2x? Just
Just
2.
two.
So you'll multiply here and divide here. Now
Oh,
you
I
just
see.
say
Okay.
that now you just say that the antiderivative of e power 2x times 2 is e power 2x. Sorry,
Mm,
plus e. You got this? Let's see
yeah, yeah, I
one more
understand. I
e to the
understand.
power. Okay. Let's see this part, the third part, sec square 3x. Let's look at this sec square 3x. Integrate of sec square 3x dx. You know the antiderivative of sec square x. What is the antiderivative of sec square x?
Tan x.
From, yes, tan x plus c. But here we have sec square 3x.
Mm-hmm.
So it is somehow different. What you will say here, you'll say that as we know that the derivative of tan 3x. How would you differentiate tan 3x? What is the derivative of tan 3x?
3 sec squared 3x.
3x. So look at here. Compare these two things.
Mm.
What is missing?
The 3, yeah.
3 is missing. So in order to integrate this function, which I am naming as I, so I need a 3 here, right?
Mm-hmm.
So I would divide by 3 outside and give a 3 inside,
Mm-hmm. Mm-hmm.
right? Now,
Yeah, yeah.
whose derivative this, which function has this derivative?
Tan
Ask
3x.
yourself. Tan 3x. So simply write down tan 3x. That's it. Is it difficult?
That it makes sense. It makes sense.
All right.
I get it. I get
Let's move ahead. So this is the general formula
it. Mm-hmm.
to compute the antiderivative in general. You can prove this as well. Now you have to see just what is missing. What is missing? You will divide by that
Yeah.
simply. Now, in order to prove this formula that antiderivative of f prime f x plus b is this, what you will do, you will differentiate the right hand side simply in the derivative of the right hand side. Uh, plus c. What is the derivative of right hand side? One over a can be kept outside because it is a constant. And
Mm-hmm.
derivative of f is f prime a plus b. And derivative of the inside function in the argument should be multiplied here because of the chain rule plus derivative of constant is 0.
Mm.
So this a will be cancelled out and you will get f prime x plus b. Prove.
Okay.
So that means if you know what is the antiderivative of a function, you just divide by the derivative of the constant function inside the argument. That's it.
Mm-hmm.
Let's
Yeah.
let's do it this way. And now this is a formula you can use it.
Mm-hmm.
For example, let's see. Let's say one thing. What is the antiderivative of sine 2x plus 5? What is? You can now write directly using this formula.
Oh yeah. Well, now it's just half minus cosine 2x plus 5, right?
Exactly.
Yeah. Oh, okay.
Now look at here. There are a few other examples as well. Now this is again the same thing. Part A, we need to integrate
Mm.
dx plus 2, please. Yes. Uh, do
Mm.
you know whose derivative is this? Whose derivative is this? Derivative of which function is 1 over x?
whenever x is ln x. Okay.
Exactly. So the derivative of log of x is 1 over x. But here we don't have log of x. We have, sorry, we don't have 1 over x. We know the antiderivative of 1 over x is log of x. Okay.
Mm-hmm.
Because derivative of log of x is 1 over x, that means the antiderivative of 1 over x should be log of x plus c. We are giving a modulus, we are putting x in modulus sign because we know that the domain of a logarithmic function is uh, positive values. Okay.
Mm-hmm.
Log is not fine for negative values. That's
Yeah.
why we are giving this modulus. So, what do you think? What is missing here?
Um, just a
Three,
three,
three is
but
missing.
yeah,
Just
yeah.
a three is missing. So, what you do, you would multiply and divide by 3. Multiply 3 inside, and now you can simply write that this is the derivative of log of 3x plus 2. Because we know that this is derivative of log of 3x plus 2. That's it.
Mm-hmm.
One simple formula uh, of finding antiderivatives of such functions is this. Let me tell you a simple rule.
Uh-huh.
Whenever we have function in the denominator and its derivative in the numerator is available, exactly this, then the antiderivative of such quotient, when we have function in the denominator and derivative in the numerator, then the
Yeah.
antiderivative of such quotients are like this, log of the denominator function. Simply, this is a formula I'm telling you.
Oh,
Maybe
okay.
it is not written like this in the book, but this is the formula. So, for example, you can use this formula. For example, we have integrate 5x minus 3. So you
Mm-hmm.
have to see what is the derivative of the denominator function. What is the derivative of denominator function?
5.
5. Is it 5 available in the numerator or not? No. So
No,
what
yeah.
you'll do, you will divide by 5 and make it available here. We can divide outside by if by a constant, not by a variable. But if you are dividing and multiplying by a constant, you can do it. You can make 5 available here, right? So now you see function in the denominator and derivative is available in the numerator. So the formula
Mm-hmm.
is you just uh, antiderivative is log of denominator function. That's it. Simply.
Okay. I see.
Same
Mm-hmm.
is in this example. Same is in this example. You see, what is the derivative of the denominator function? What is the derivative of denominator function? It is 3.
So
Are
yeah, I see
you
make it
listening?
available. Okay.
Okay.
Yeah,
Yeah,
yeah, yeah.
put it log of the denominator function. That's it. And we can do more examples on this. For example,
Mm-hmm.
cosine x divided by sin x. What is the derivative of the denominator function?
Cosine x again.
It is available in the numerator, right? So
It
it is
is,
like
yeah, yeah.
this. It like this. So you just take the log of denominator. That's it. You can write it like this. Okay.
Okay. Yeah, yeah, that makes sense. That makes sense. Manipulate it. Okay.
So after that, we have this huge exercise number 11b,
Oh, wow.
and just tell me we are going to discuss from each of the numbers. Number one, uh, different questions we can attempt, just like A and D are similar. So tell me which
Mm-hmm.
one I should we should do. Which
Um,
one?
let's do 1C.
1c. All right.
Yeah.
Let's do 1c. Uh, yeah. So let's do 1c. Integrate 4 times e to the power x plus 5. This 4 has nothing to do with the integration. We don't need it here. You can take it outside simply e to the power x plus 5. Okay. Now ask yourself,
Hmm.
what is the derivative of the power? This power. What is the derivative of this power?
Just one, so
1. So 1 is already available here.
nothing, I guess.
Yes, 1 is available. So just you can directly
Hmm.
write the antiderivative of e power x plus 5 is same e power x plus 5. That's it.
Like, okay. Oh, okay.
Okay.
That makes sense.
Or
That
we
makes
can
sense. Didn't know it was that easy.
let's yes. You just need to keep in mind that if we have a function like e to the power f of x, e to the power f of x,
Jeez.
then then the derivative of this power should be available here. Derivative of the power should be available here. Then the antiderivative will be same e power f of x. Simply.
Uh-huh.
Fine. Let's
Yeah, once
let's
again, sorry,
okay.
when you
Let
say
me
what's
explain it
available,
again. Yes. Let me explain this thing. This is actually coming from chain rule. Let's
hmm,
see. We want to prove that antiderivative of this is this. Right?
yeah,
Let's prove this. That the antiderivative of this is this. This function is this e to the power f of x. So you will see that where is this derivative coming from? Why this should be here? This is the question, right? Why this should be available here?
yeah,
So you will see it's when you will prove it. How can we prove this? That the antiderivative of this function is e power f of x. We will simply differentiate the right hand side. If it is coming to be the integral of the left hand side integral, then it is done. So you just take the derivative of e power f of x. No need to take the derivative of c because we know derivative of c is 0.
yeah,
Okay? So just take the derivative of
yeah,
e
okay.
power f of x. How you differentiate e power f of x?
Use chain rule. So, oh yeah, you
E
just
power
multiply
f
the
of
two derivatives. Okay.
x.
Yeah,
The derivative of e power f of x is same e power f of x, but you have multiplied the derivative of f of x, right? And this is chain rule.
yeah, yeah,
We are using chain rule.
yeah.
This is done. So now you see where is the derivative coming from. This is coming from the chain rule.
I see.
So this should be available here. If otherwise we are unable to integrate. If this is available, you can integrate the derivative of e to the power function is same e to the power function. But the availability of the derivative
Mm,
inside the integral is necessary. That is compelled by the chain
yeah.
rule. So let's an example e to the power 5x squared plus 9. Can you integrate this? So you have to see
Um,
what is the derivative of the power function. What is the derivative of this?
10.
Hmm?
10, right?
10x. No, 10x.
10x. Oh yeah, of course, 10x. Yeah, yeah.
The
Um,
derivative of 5x squared plus 9 is 10x plus 0. It's 10x.
yeah.
So we
And
are
then
unable
for
to integrate this because the derivative is not available here. How can I make it available? I can make
yeah,
10 available, but I cannot make x available, right? So we are unable
mm,
to integrate this.
yeah,
Unless we have x here. Now we can integrate this. What is missing? Damiano, what is missing now?
Um, you
Vx here.
what is what? Oh, what is missing?
What
The
is
10. The 10.
10
So
is
you add the
missing.
10 and then
So
take it out.
what do you do? Multiply 10 here and divide
Yeah.
10 here. Now the derivative is available, just like this. Derivative is
Hmm.
available. Now we can just see that the put the derivative equal to e to the power whatever the function in the power is e to the power 5x squared plus 9. That's it. Okay, what is next?
Okay. That makes sense. That makes sense. That's easy enough. Um,
Which one? Quickly.
let's do two E.
This one.
Two part E. Yep.
All right. So there are three functions, three terms, first term, second term, and third term. We will integrate each of the
Hmm.
terms separately. Plus antiderivative of sine 3 minus x plus antiderivative of cosine t minus x. So what is the antiderivative of e to the power function? What is the function in the power? 3 minus x? 3
Yeah.
minus x? What is the derivative
Hmm.
of 3 minus x?
1. So you can just leave it.
No, 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 no. What is the derivative of 3 minus x? It's not 1.
Oh,
No
minus 1
problem.
times.
What is the derivative of t? It is 0. What is the
Yeah.
derivative of x? It is 1. The derivative is negative 1.
Oh my God, yeah. Oh, right. Makes sense. Makes sense.
So no problem. No problem. So what did we just see? That the derivative should be available here. If it is not,
Hmm.
you you should make available. How I multiply negative 1 inside and negative sign outside. Is it
Yeah.
fine? Okay.
Yeah, yeah, that makes sense. That makes sense. It does.
Again, what function is in the argument of sign? Same function.
Oh yeah, same thing, minus 1.
Same thing. So we will multiply. So derivative of this argument function should be here. If it is not, you will multiply minus 1 outside and minus 1 inside. This is fine.
Hmm.
Similar cases
Yeah.
here.
Yeah, same
Multiply
thing, minus 1.
minus
Okay.
outside and multiply minus 1 inside in order to make this derivative available. Now, when the derivative is
Hmm.
available, we will just simply integrate. So e to the power 3 minus x has the same derivative, e to the power 3 minus x. Just the availability of the
Yeah.
derivative is important. Derivative is same, antiderivative is same. What is the antiderivative of sine?
Here will be positive because it's negative cosine 3x times negative 1.
Exactly, exactly.
3 minus, yeah.
What is the antiderivative of cosine?
Just sine 3 minus
Sine 3
x.
minus x. You are done.
Hmm.
Negative e power
Okay.
3 minus x plus cos 3 minus x and minus sine 3 minus x. Let's see. Any questions?
All right, that makes sense. No, that's all fine.
Next.
Okay, let's do 6, 7, and 8 because they have the little exam question mark next to them.
It's okay. Let's discuss this one first of all. Then we go to these questions.
Okay,
What about D?
okay, okay, okay.
This. What about D?
Oh, I didn't see that. That looks awful.
Can you solve? Can you solve this?
Um, is it reasonable to split the fraction up,
Yes.
or is
Yes,
that
of course.
not good move?
So we will split the fraction. uh,
Yeah.
3 over sine square x over 2,
Mm,
and the argument minus 2 cos x over 2 divided by sine squared x over 2. And we will
mm,
integrate both of these functions separately. Let's integrate them
yeah.
separately. Okay. So 1 over sine square. 1 over sine square can be written as how? 1 over
Uh,
sine
one over
is,
squared is cosec squared. No.
yes. And it is reason
Yeah.
why we have to write it like this because we know the derivative of cosec square. Sorry, antiderivative of cosec square. It is
Yeah.
minus cot, right?
Yeah. Yeah.
Similarly, uh, let's write this cos over sine square is 1 cosec and 1 cot. Is it clear?
Oh yeah, because over sine. Okay, yeah, makes sense.
How?
Because
Ah,
cosec is because if you split it up further, it's one over sine, which is cosec, times cos over sine, which is cot,
exactly.
right?
So now,
Mm.
no. Whose derivative is cosec square? Which function? Whose derivative is this? Do you know any
Negative
function whose derivative is cosec
cot.
square? It's negative cot, right?
Yeah, no.
Negative cot. But here we have a function in the argument which is x over 2. It is
Hmm.
not simply, we know that the antiderivative of cosec square x is negative cot x. Negative cot x. Simply. All right.
Yeah,
But we don't have x
yeah,
here. We have x, this simple.
yeah,
This is simple. But we have x over 2 here in the argument. So this is different. We have to use reverse chain rule here. So what is the idea is again the same that if we have another function, something else other than x, because if we have x, then we can simply write antiderivative. If we have some other function
yeah.
other than x, then the derivative of this function, argument function, should be available here. Should be available here. If it is not, you have to make it available before integrating. What is the derivative of argument function? What is the derivative of x over 2?
Half,
Half.
1/2.
So in order to make half available, you need to multiply 2 outside and
Oh yeah, of
half
course.
inside. Chain rule is compelling us to make this derivative available here before
Hmm.
integrating. Otherwise, we are unable to integrate. These
Yeah,
all questions are same, right?
yeah.
Again,
I see.
again, the same question is here. Do you know any function whose antiderivative is whose derivative cosec x into cot x, or what is the antiderivative of cosec x times cot x? What is
Mm.
the antiderivative of cosec times cot?
Minus cosec x, isn't it? It's just minus cosec x.
Yes, right, minus cosec
Yeah,
x. So uh, this is simple because we have x here and x here. So we just
yeah.
write negative cosec x. This is simple. What if we have some other function in place of x? What you will do? You will say
Find the
that
derivative when available.
we have to make the derivative of this function available.
Hmm.
So x over 2 has a derivative 1 over 2. I am dividing it here and multiplying it here. Any
Yeah. Do you have to do it
problems?
twice in terms?
Sorry?
Do you have to do it
Sorry?
twice if there's two different terms? Do you have to
No, no,
take
no, no, no,
away?
no, 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 no.
Oh yeah,
Just have
fine.
to.
one derivative. Oh, yeah, yeah, of course.
Just one time, just one time. Okay. So two threes are six. And now, when the derivative is available, now you just see what is the antiderivative of cosec square.
Yeah,
Availability of
minus cos.
derivative is important. There is no any influence of this derivative on the right hand side. What is the antiderivative of cosec square is simply minus cot x over
Hmm.
2. That's it.
Yeah,
2 times 2 will give us 4. What is the antiderivative of cosec times cot? It is negative
negative cosec. So
negative 4 6.
cosec
Here
x.
we have x over 2 plus c.
Hmm.
That's it. You need a lot of practice to uh, ex- uh, experience on this using this, how to use the
Yeah,
reverse of chain rule.
this specifically now.
You know basic things, but you need experience how to apply this reverse chain rule.
Hmm.
Okay, now which one you
Yeah,
are interested to solve now?
we should do 6, 7, and 8. They look like big questions.
Okay. Okay. So number 6 says that
Hmm.
suppose that this is sorry, given is the antiderivative from 3 to b of 2x minus 6 squared dx is 36.
Hmm.
So in order to here we have to find the value of b. So in order to integrate this function, we know that we can simply integrate x squared. What is the antiderivative of x squared? We have just seen in the previous exercise by using the power rule. What is that?
A, a third x cubed.
X cubed divided by 3. Okay.
Yeah.
But what if we have some other function other than x inside the power f of x power n? What is the rule in this case?
Oh,
The rule is
I'm
same.
not sure.
Rule is same. Add 1 to the power and divide by the new power. The rule is same.
I've seen this before. Yeah.
The rule is same. But you need to keep one thing in mind that if we have some other function inside the power inside exponent, then the availability of the derivative is important. If derivative is available, then you can integrate x. This is again the reverse chain rule.
Yeah, yeah, yeah.
Same,
We just did this.
the
Yeah.
same reverse chain rule, right?
Hmm.
Is it
Hmm.
okay?
Yeah.
Or you want to see how is this coming from? Where is this derivative come from?
Yeah.
You
Yes,
want to
please.
see? Okay, let's
Yeah.
prove
Yes,
this
please.
formula. Uh, so you to keep in mind that this derivative is important here. This should be available. So you can use this
Hmm.
formula. How is this coming? Let's prove this. In order to prove this, you need to differentiate the right hand side. Let's see what happens. Differentiate the right hand side. So how you differentiate this function? This n plus 1 is constant, just keep it outside. And derivative, the power of function. Basically. Okay. How to differentiate this now?
Um, you
Using
multiply,
power
then
rule,
take the
power will
yeah.
come down and subtract 1 from the power.
Mm-hmm.
Subtract 1, right? This is the formula or power rule.
Yeah.
And multiply the derivative of the inside function, the argument function. This is the chain rule.
Oh yeah, yeah, yeah.
You know this. For example, if you are differentiating, say, 2x plus 3 power 9, how you differentiate this? How you find the derivative? 9, 2x plus
Uh,
3 power 8. This is how you differentiate.
Two, yeah.
Hmm? Do you remember or not? This is from the
Times two,
derivative.
no. Yeah, yeah.
Times 2.
Mm-hmm.
Why you are multiplying this 2? Because of the chain rule. You are using chain rule here. Because power of a function is a composite function actually. It's a
Yeah.
composition. This is a
Mm-hmm.
composition. So wherever there is a composition, we need to multiply, we need to use.
No, that's
You
all good.
understand this? You have any question you can ask now. So you see,
Yeah.
this one will be cancelled and one will be cancelled out like this.
Mm-hmm.
And we will get simply the left hand side, it is fx over n. So this is that whenever we integrate a power, we should see that the we should make
Mm-hmm.
sure that the derivative is available. If derivative is available, then you will simply add 1 to the power and divide by the 2 power. Okay, Damiana.
Mm-hmm.
Now you do it. Now let's go to our question. Now here we have to integrate find the derivative of 2x minus 6 power 2. So how can we take the antiderivative? What inside function inside the power?
The derivative of the inside is two.
So 2 should be
So,
available here. Should be available here. If it is not,
mhm,
we will
yeah.
divide by in order to make it available. So
Mm-hmm.
now we have divided by 2. Now it is available here. We can integrate. What is the derivative of power? Is simply add 1 to the power and divide by new power. Add 1 to the exponent and divide by the new exponent. But we have a definite integral, so we have limits as well. Do you have any questions?
Oh, your audio cut out. Oh, okay, you're back.
Yeah, I think there are some internet issues. Do you listen me uh, properly?
Yeah, yeah, I can hear you, but you're cutting out. You're cutting out. It's okay.
Okay, thank you. So this 2, we can divide it on the other side and 3 can be multiplied to
Mm-hmm.
the right hand side. So on the left hand side, we are left with 2x minus 6 power 3 and lower limit is 3, upper limit is b. And on the other
Mm-hmm.
side, we have 36 times 6.
Yeah,
This 3 and this 2, both of them will be multiplied to the right hand side. 2, 3, the 6 will be multiplied.
yeah.
Okay, so how much is this? Use your calculator and see how much is this. 6 times 36, we will have to put it here. And just apply the upper limit. So upper limit will be this, 2b minus 6, and the lower limit will be 6 minus 6 be 0. How much is this? 6 times 36.
We're not 216.
216. Are you sure?
I think, yeah.
Okay, it's
30
6
times
cube.
6, 180 plus 36.
So it's
Yeah.
a 6 power 3.
Oh, yeah, yeah. That makes sense.
So
Oh, they.
in order to find B from here, we just simply take the cube root,
Mm-hmm.
both sides. So 2B minus B equal to
Yeah.
6. So 2B will be equal to 12 and B will be equal to 6. 6.
Mm-hmm.
Check the answer if it is correct.
Well,
B is 6.
um,
11B
what chapter
6.
is it? Chapter
11B
11.
6. 11B 6.
Mm-hmm.
11B 6 and the answer is 6.
11B6. Yeah, 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 we're right. Yeah, it's correct. It's correct.
Next.
Can you hear me?
Yes, yes. So number 7. Back to the new page, and this is number 7. Can you solve it?
Sure.
Now, I want to see
Um,
how you do it. Find the
okay.
value of k.
Let me go to like. Mm-hmm. Okay, so is that e to the x at the top, or what is that? What number is that?
E to power 8. 8. It's 8. 8.
Okay,
Yes, yes.
e to the power 8, 1 over kx. Um, uh, surely this integrated is. Okay, so if we
What
make
happened?
the derivative available, the derivative will be k, and then we divide it by k here, and so we're left with um
No, 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 no. Why don't you just keep 1 over k
log
outside?
of.
Why don't just you keep 1 over k outside? 1 over k constant. Take it outside. Simply.
Oh yeah, of course it is, isn't it? And then that's it, isn't it? Times 1 over k equals 1 over 4. And then,
But we have limits as well. It's a
so,
definite integral.
yeah, yeah, yeah.
Apply the
Oh, yeah, true, 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 true. Okay, so we don't mess with this yet. Okay, so we have what, e to the a and then e squared. Okay, if we take this up. Can I take the k to this side before I apply the limits, or does it have to stay
yes,
on this
yes.
side first?
Yes, you can take the k to the other side.
E to the 8. Doesn't this cancel to just being 8?
Yes.
Is that it?
Yes, I think it is correct. But
That's right. It is. It is.
you have to. Can you erase all this?
Oh yeah. Yeah, sorry.
Yes. But one thing you need to keep in mind that whenever you are attempting a question, you should
Yeah.
attempt it systematically. That 1 over k is taken outside and we are left with e squared e8 1 over x dx equal to 1 over 4. This is given. So when we integrate 1 over x, we will get log of x and we have to apply these limits equal to 1 over. Now take k
Yeah. I
to
could have
the
laid it
other
out clear.
side and take k to the other side and 4 to the left side. So we can write 4 here and apply the limits. Log of e8 minus log of e2 will be equal to k. Okay. 4 times
Hmm.
this will be 8 log of e minus 2 log of e. Now log of e, that they are inverse of each other, they will cancel each other.
Yeah.
So we will get, so we know that log of e is 1 actually.
Hmm.
So we'll be left with 8 minus 2 equals to k and 24 equal to k. So this is a required value. So you see,
Yeah.
I'm writing systematically. This you need to write
Hmm.
it like
Hmm.
this if you are attempting any exam. So this is a good way that we are given this. Very important that you write
Hmm.
systematically or not.
I
So
normally
let's
do when it's on paper. I normally do. It's just more difficult to
okay.
write, with the pen.
Any questions?
No, that all makes sense. That's all clear. Yeah, we started the chapter on Tuesday, and we've got more practice on it tomorrow. But I definitely feel a bit more confident with it now. So I'll just get.
So what should we do next?
Oh, we
11C?
should do eight, right? We haven't done eight yet, and
Which
eight is
one?
worth
A.
7 marks. 8 is worth 7 marks.
8. This
Yeah,
one.
yeah, yeah.
Okay. Okay. Should we do it now?
I want to see what it looks like.
Sorry.
I want to see what a 7 mark question looks like.
See.
Mm.
So where is K?
In front of the X, so it's gonna be.
K is in limits
Oh,
as well. K is in limits as well.
oh, is it? Oh shit.
Okay, let's solve it. So given as
Mm-hmm.
the antiderivative of pi over 4k, is it pi over 4k?
Mm.
Okay, pi over
It looks like
3k,
it, yeah. And the other one is. Yeah.
1 minus pi sine kx dx equals to pi times 7 minus 6 square root of 2. So look at here now we have two terms. First term is 1, second term involves sine. So what we will do,
Mm-hmm.
we will integrate the two terms separately, integrate one separately with the same limits, and integrate the other term separately with the same limits.
Okay.
Any questions? Any problems?
Pi sine K. No, that makes sense. So you can split it up as long as it's got a plus or a minus in between them, right? Like you couldn't split it up if it was like two times the other things, but you can split it up if there's.
Exact, exactly.
Okay.
Because def integrals are linear, so we can take the integrals
Uh-huh.
of separate terms. Due to their linearity property.
Hmm.
So what is the antiderivative of 1? It is x, and
Oh
we
yeah.
need to apply the limits.
Mm.
K is phi outside. We don't need it here. What is the antiderivative of sine kx?
Negative. Oh,
Okay, k is missing. Derivative
it's gonna
of
be
kx
negative
is k,
cos ax over k, right?
as it will be negative cos kx over k,
Okay. Yeah.
and the limits are pi over 4k, pi over 3.
Oh, do you not include the pi in that? Oh, interesting. Okay.
Pi is a just constant. We have kept it outside.
Hmm.
Okay. So now we will apply the limits here. Upper limit is pi of 3k minus lower limit is pi over 4k minus minus into minus will be plus pi over k. This k. Is it okay?
Uh, uh, hang on, pi over k. Oh yeah, yeah, yeah. Okay, yeah, that makes sense. Yeah.
This k can be kept outside.
Mm.
Now apply the
Yeah.
limits. Upper limit is pi over 3k times k will be pi over 3. Pi over 3. And similarly, applying the lower limit, pi over 4k will be pi over 4. K will be cancelled with this k. Do you hear me?
Yeah, yeah, yeah. Just a minute, pi over four. Yep.
Rest of the things are same. So just you need to put the values here and find k. So k is everywhere in the denominator on the left hand side. K is here, and k is here. That makes sense?
Yeah.
So
Yeah, that's all fine.
if you need k, then k will be equal to what? Pi over
Oh,
3 minus pi over 4 plus 2
uh,
pi times.
plus
What is the value of cosine pi by 3?
um, is it
What is the value of cosine pi by 4?
um, that's 30 degrees.
Yes.
Um, but I don't know how to put that into.
So this is the
I don't
value
know
of
what
k.
cosine of 30 is. I don't know what cosine of 30 is. Oh yeah, yeah. Let me get the calculator. Take that. Oh,
Pi by 3 is 60 degrees. Cosine 60 degree is equal to 1 over 2.
mm.
And pi by 4 is 45 degrees. Cosine 45 degree is 1 over square root 2.
Hmm. So we end
So
up with
uh, do you agree with
see.
this last equation? How this k is coming like this?
Yeah, yeah.
Hmm?
Mhm.
I have just multiplied k both sides, so these three k's will be
Yeah,
cancelled
yeah,
from
yeah,
here.
you just factor it out. Yeah, that makes sense. That makes sense.
And divided this thing to the left side.
Mm-hmm.
Now just calculate all this, put it into
Yeah.
your calculator and see. Okay, you can cancel out pi as well. You can cancel out pi as well. And then you can just simplify. You can write it like this 7 minus 6 root 2, 1 over 3 minus 1 over 4 plus 1 over 2 minus 1 over square 2. Because pi is
What are
everywhere.
those?
Pi is here, pi is
Yeah, what are
here,
those
pi is here.
brackets?
Sorry?
What do those brackets mean? The squiggly brackets. Does that represent like multiplied or?
It's a simple brackets. These are simple brackets. You can give square brackets or these parentheses. It's okay. No problems.
I mean the big ones, the squiggly ones, the ones that are
Nothing,
like.
nothing. They don't represent just the multiplication. Just multiplication.
Oh, okay, yeah.
Add them and divide by this. You will get your answer.
Hmm.
And also tell me that the answer is correct or not from the book.
Okay, so all of the stuff in, inside the big bracket adds up to 12.
Yes.
So then I assume you just cancel the 2 and then it becomes 1 over 12. And yeah, that's correct. So